Hey there everyone, Ryan Schul here. Welcome to my channel. So today I want to talk about airport gate assignment optimization. So I have several videos on my channel now about optimization, probably getting up to a couple dozen at this point. It's quite a bit out there. So this one I haven't discussed. So I want to try to dissect it and jump in and kind of pull back the layers of the onion and see what we can find here. So I did a little research on this, and basically if an airline arrives late or maybe even early and there's no place for it to park, it needs to go somewhere else, right? Short distance from where people actually deplane. Enplanement means getting on the plane, deplanement means getting off the plane. So basically, a tow vehicle or some type of tug crew has to pull the plane over to the place where the people sit on the tarmac for a short bit of time until something opens up, and then they can, deplane. So that is the goal here. But there's costs for this, right? There's costs for everything. There's no free lunch in this world, right? You don't get you don't get anything for free. So you want to try to get the people from the origin to the destination as quickly as possible, but sometimes things come up, and if there's delays or holds, it can have a ripple effect and cause the airline to have these tow charges, and it can become pretty significant. I'll show you at the end here how it can easily run into millions of dollars. So I'm going to go ahead and I've got some notes here. I'll let you guys read this. I don't want to go through everything piece by piece. There's a lot of stuff here, and I don't want to just talk ad nauseum for 15 or 20 minutes, but the notes are in there. This is all from my research. So if you want to go ahead, take a look and examine that more closely, go for it. By all means, go for it. So I have some data here that I downloaded from the web. This is a CSV file from the web. And if you go down here, I have a reference to the file. So you can see, okay, it's doing this thing again. Let me refresh this. What's going on here? Half the time it works, half the time it doesn't do anything. Then you refresh it and then it works, right? So, okay, so anyways, the control end, let's go to the end here. So the references at the end, if you want to take a look at this data, definitely I would encourage you to do that. And let me get over here. So that looks like this, basically, okay? Resource download, and it comes from Kaggle. Just download, hit the download button down there. Okay, and you will get your CSV file that looks something like this. This is mine right over here. Okay, and where's this right over here? Yeah. Let me jump back to the top. Okay, so I'm gonna have to rerun this because it just faded out on me. Computer's getting old and it doesn't really do what you would think it was gonna do. Okay, so I do have a couple parameters while the file is open. It's a pretty massive file. And by the way, I'm just gonna use 1% of the data because if I try to do the analysis on the whole file, it's gonna run for days and days, and maybe it won't even finish. I don't know. The data set is pretty massive. I have a small T14 ThinkPad solid state drive, but this thing is not a racing machine, right? So you have to kind of treat it gently, with respect. You need patience to do these types of analysis, right? Like this machine is just not going to crank through volumes and volumes of data. So I'm going to take 1% of the total amount of the data and just do the analysis on that. So it's weird. I thought I just opened the data. It's not opening now. All kinds of issues here. It's like one thing after another. Okay, so this is running. So again, it's going to take a little while to run. So I'm just going to take 1% of the data, but I'll give you the setup right here. We have a dictionary with key value pairs. So I have the flight date, airline code, number, flight number, origin, destination, arrival time, distance traveled, things like this, right? Exactly what you would expect from any kind of airline. They're going to capture all these data points and probably a few others as well. So we can go ahead and build a scheduled actual date time calendar, okay, based on the data that we have. So this is called feature engineering. You take the features that are given to you, okay, but if you don't have everything you need, sometimes you have to modify the features into other forms, right? So you could have like a time and date stamp. Maybe you just need the day of the week. Maybe you need the hour of the day. Maybe you need to know, is it a weekend or a weekday? Maybe you need to know, is it from 1 a.m. until noon or noon until 12 a.m. at midnight, right? So there's all kinds of different criteria and requirements that you might need to do to prepare the data to be in a state for you to analyze it. So that's called feature engineering. Okay, so the file finally opened here. I get a view. Again, there's more than a million records, so I can't see everything here. I mean, in this Excel view, but everything is in the CSV. But that's my point, because the file is so massive, I'm not going to run the analysis on the entire thing. I'm only going to look at 1%. And even at that 1%, it's kind of laggy and kind of a little bit finicky here in what it can do. So let me come back to that. All these things just go so slow. I almost lose interest after a while, but not quite. And keep going on. Like what's his name? Shiffius, whatever, pushing that rock up the side of the hill, pushing the boulder up, and then it goes down. You have to do it again next day, do it again the next day, and again, again. That's your life, right? Like you're Shiffius, and you have to push that boulder up to the top of the hill, and it's gonna fall down, and you do it all over again the next day. So, anyways, this is the data frame I'm getting. The departure schedule, departure. Let's see, for fly date and get departure and then arrivals. Okay, so we're getting departure and arrival, just some basic things. We have to get some basic conversions over here to get this into the right format. Okay, and by the way, if you ever try to do these things, you'll discover pretty quickly if there's one single record in the entire data set that Python or Pandas doesn't recognize or doesn't understand, it's going to throw an error. So if you use this term right here, comma errors course equals true, or just comma errors course, this is going to force it to be true and continue. So even if an error is flagged and something jumps up, the code is going to continue to run and you can still do the task that you need to do. If you don't do that and an error is found, it's just going to shut down and that's game over right there, right? So you don't want that. You want to be able to finish whatever you start. So this is a nice little trick to employ for that, okay? So you get the overnight adjustment and the actual rollover when both times exist. So there's a little trick. You have to kind of like force these things to work because no airline is going to land guaranteed by 11:59 p.m. and it just cuts off there. And then the next day starts at 12:01 a.m. It could go overnight. And sometimes with these data sets, the way the data is presented, it can be a little bit confusing to pandas or even to some users or to some stakeholders or whatever. Where is the overlap, right? Like we kind of know it's midnight, but the computer doesn't necessarily know that's the end of the day. And some of these errors, some of these data sets can be very confusing. So you have to force it to say, okay, one day ends at 11:59 p.m. and the next day begins at 12:0001, 1 second after midnight. That's the new day. So you just have to tell the computer what's going on here, and then it's going to be able to do the analysis correctly. Without that, sometimes the machine gets confused and you'll get some weird stuff that just makes no sense. So that's why if things run overnight and the data handles that by nature, it's fine. If it doesn't, you have to force it to say, okay, this is the first day and this is the second day, and don't blend those together because the analysis won't make any sense. And if you take a look at that, you'll see what I mean, right? So here's my 1%. I'm taking 1% of the data frame. Okay, so it's over or exactly 3 million records. I'm going to analyze 30,000 of these, and we'll still get a nice output. We'll get what we want, but at the end, we have to multiply everything by 100 times because we're taking 1/100th of the volume of data to do the analysis. Okay, so that's it. So we're looking at departure dates and arrivals dates and things like that, and total seconds, flight time, right, divided by total seconds by 60, the total time divided by 60. We are looking at the carriers over here. And what I really want to get from this data set is flights, the account type, the arrival, departure, the turnaround, minimum time, and then the preferred. Okay, so we'll see what this is in just a minute. And then we'll have things like total distance, total elapsed time, total elapsed distance, and things like that. Okay, then we take everything, we append it into this list called records. If I search for that, you'll see that at the beginning. So there's my blank list. I like these lists a lot. They're very flexible. You can append data to it. I don't really like working with tuples. Tuple is another data type in Python. I hardly ever use that. There might be a time and a place for it, but it's pretty rare, at least based on my experience. But I love lists, so I'm appending to a list, and I have a dictionary key value pair. Here's the key. The value is on the right. Okay, so we'll see this key value pair over and over. And then another thing I like is data frames, and we're going to be joining, or not joining, we're going to be creating a data frame in just a minute here. And it's coming basically from here. This comes from the record set. You can see records is a list. We're feeding that into a pandas data frame, and then we have our flights _df, and we'll see what that looks like in just a minute. I think this is going to take a couple of minutes to run here because the data set is big. Even though it's only 1/100th of the original data set, it still takes a while to crank through all this, right? So I'm going to hit the pause button. I'll be back in a few minutes. All right, guys, this looks good now. So we know at JFK we had 461 arrivals, 497 departures, and the number of flights built for in this scenario is 461. Okay, based on arrivals. So this is what the data frame looks like. We have flight, AC type, arrival, departure, turnaround minutes, and then preferred. So this is the gate where they park the plane. Okay, this is all actual data in some of my lectures or whatever you call it, like these scenarios that I do and put on YouTube. Sometimes the data is synthetic and I have to create it because the data either doesn't exist in the public domain because it's private, it's confidential, or whatever. But this is actually public data, right? So this is pretty nice. We have a lot of cool stuff here that we can work with. So let's keep going. So we want to go ahead and assign gates based on availability. If nothing is available, what is the cheapest one for to be shuttled for this to be shuttled to or taxied to, whatever it's called. We have to get the plane either to the next open gate or the gate with the least wait time, right? Or maybe the shortest distance to the gate, right? And it's kind of a complex problem because we're looking at all of these scenarios together, right? We can't just say, oh, we'll go to the first one that opens up. If that is way on the other side of the airport, maybe that doesn't make sense. We can't just say we're going to go to the closest one. Maybe that won't open up for an hour, right? So we have to look at all these different criteria simultaneously and see what the best course of action is based on what it's going to cost the airline, right? So this, I don't know if it's called a penalty, but just a cost of doing business, right? If you're towed to another station or another place where the plane is parked for several minutes, 15, 20 minutes or whatever, until you can deplane, that there's a cost to the airline for that, right? So we want to try to minimize the cost. That's the objective function here that we're trying to solve for. So I go ahead and set that up. I put in a couple UDFs. Okay, so we have the defined function over here, and we are going to go ahead and start to sort the stays by arrival. And like, again, how long is it going to take us to get to that gate? What's the closest gate? And also maybe what's the cheapest gate too? Maybe there is nothing close. Maybe there is nothing that's going to open up in the next 30 to 60 minutes or whatever. But what's the cheapest place for the plane to park at, right? So we have to consider all these things. We're going to dump this into the algorithm and go ahead and look at the gate. Is there any conflict? Gate hold minutes, tow minutes, and how much is this going to cost us? Okay, let me hit Control Enter to refresh the cell. Okay, just to demonstrate, like, I'm doing all this in real time. I'm not just making up just things that kind of sound like cool or bizarre or like whatever. Like, this is all real stuff, right? So I refresh the cell just to prove that I'm doing what I'm claiming to do, right? So yeah, we have the flight, we have the type of flight, arrival, departure, turnaround minutes, and then the gate. That's what we saw before. Is there any gate conflict? So true would be yes, so we can't go there. If this is a false over here, then that's fine. So we can go to that gate. Is there a gate hold minutes? 0. Tow false and tow minutes 0. So basically these planes are at the optimal place right there, right? There's nothing that really needs to be done. If there is a conflict or a tow required, then yes, then there's going to be minutes charged over here, and then there's going to be a tow minimum fee. Okay, so I'm going to hit Control Enter to refresh this. And again, we're looking at gate hold minutes, and is it what kind of quantile is it, right? So we look at these different buckets. Is it in the bottom 50th quantile, top 90 or top 95? So 95, we're almost guaranteed, not 100% guaranteed, but 95% of the time, we're going to find the gate pretty quick, okay? 90% of the time, we're going to find the gate pretty quick, or 50% of the time, we're going to find the gate pretty quick. So when you get up to this 95%, it's almost 100%, it's almost a guarantee, but probably the hold is going to be longer because you have more of a window to access the gate, right? Here, it's just 5% lower, right? So 90% of the time, you're fine. 10% of the time, it's going to be a long wait, guys, and there's nothing you can do about it, right? But that's another quantile that we could consider, or this could be 50-50. So we might get a nice assignment to a nice gate. It's going to be quick and efficient and low cost to the airline as well. But there's 50% chance it's going to be the exact opposite, right? So this guarantees or offers more guarantee, but because you have a bigger window, you don't know how fast things are going to get done, right? If the 50 percentile, things are going to get done pretty quick, but then half the time it just won't. It's just not going to work out for you, okay? So when I run this, I think I just refresh it. So let me do it again just to make sure. Okay, so we have total stays 461. That's what we saw before. Gate conflicts 0. Total toes is only 3 out of 461, so less than 1%. Average hold is 0 minutes, so we're looking pretty good here, guys. This optimizer is definitely working. P90, so this is a 90th percentile 0, and the max is 0 minutes. So this is pretty good. We did a good job with the optimizer here. Conflict 0, average hold minute 0, 0, 0, 0. Toes, this actually had 3 toes, but 0 hold minutes, so I guess it was pretty efficient. I guess the optimizer is telling us it's pretty efficient. And toe minutes, probably 50 minutes per toe, because we had 3 of them. So 3 times 15 is 45, right? So that's conflicts and toes. And carrier summary, again, 0 conflicts. So in this column, we're looking pretty good. Conflict rate, nothing, nothing, nothing. Toes, this guy had 2, so 50 minutes for toe. This is 1 and 15. This is 2 and 30. So again, optimizer is pretty much working. Anything below here, no issue whatsoever. Couple little issues over here. But again, the optimizer is helping us big time. I'm going to show you in a couple minutes what the result would be like, or what the scenario would look like if you did not optimize, how planes were assigned to different toll gates, right, to deplane. So we saw here conflicts is 0. So upon arrival, they found the gate every time. That's fantastic because the optimizer is telling us what's available. Is this available? Is this not available? What's the wait time for this? What's the distance to get to this other one, right? So we're looking at all these different criteria. This is a greedy algorithm, so it's assigning based on fixed gate order, and it scans and looks at, what's free right now, what's coming up in the next couple of minutes, 5-10 minutes. Is there an occupancy? Is there no occupancy, right? What's the default turnaround time? Is there sparse arrivals, like early in the morning and later in the evening, or maybe even early evening? Maybe there's fewer arrivals. If you're going at rush hour, there's probably going to be a lot of traffic, and you're probably going to be waiting for a while, right? But still, we're still trying to optimize the solution here, no matter what time of day. I'm just saying in the morning and later in the evening, it's just going to be easier. So let's keep going with this. So we have the average hold time and the P95 hold time. So again, the 95th percentile, 95% of the time what the outcome is going to be, but you could fall in that 5% of the tail, and you could just have a long wait time. Nobody expected it. There's an issue that you couldn't foresee, you couldn't anticipate, something just came up, and you just have to deal with it, right? But in the 95th percentile, we know 95% of the time, almost precisely what's going to happen. It's only the 5% kind of holdout or unexpected, unanticipated outcomes that these things can get you, right? So let's keep going here. So we have a gate assignment for the airport. The total stays, total toes. The window for the toe is 15 minutes. So we've established that, and we're going to look at the peak simultaneous gate occupancy, right? And see if we have any conflicts, or if we can just go ahead and tow the plane right in. So for JFK, again, 461. Conflicts 0. So the optimizer is definitely working. 3 toes. Okay, we saw some evidence of that before. And over here we can have the flight number, the arrival, and then the date, the departure date, turnaround minutes, preferred gates. This is the actual gate where it went. Gate conflict, no, 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 no. So these are all false. This looks fantastic. So the optimizer is working. It's doing everything great over here. Utilization. So here, based on the gate, we can see how utilization is, like how much the gate was used, right? So is the gate overused or underused? 75% is fine. Once we hit 100%, then obviously no more planes can go. We're already probably starting to create a backup or a traffic jam there. So 75% is fine. If you go over that, it might be a little bit risky. 32 is fine. 29, 23, these are fine. So these are actually underutilized over here. This one is probably utilized at a capacity that could probably handle. I don't know if I want to go too much over that, because if you get to a point where you hit a tipping point, then there could be a disastrous consequence, right? So you don't want to deal with that. So again, we're trying to minimize tows and overall delays for the airline, for the passengers, for the crew on the plane, right? Win-win-win. If we can optimize this scenario, everybody wins. Let me go ahead and hit Control Enter to create a plot. I always say a picture is worth 1,000 words, right? So if you can visually show somebody what something looks like, they can say, oh, yeah, I know what that is. Eureka. This makes sense. I've got it. So we have a start and end time. The stays are going to be are going to include the start use, finish use, and then task. The task, start use, finish, flight, carrier, the type, tow, gate, and minutes, right? So we're going to go ahead and plot this using Plotly. If you've never used Plotly before, Google it, check it out. Talk to ChatGPT. There's all kinds of great examples out there. I use these charts pretty much exclusively in my Jupyter notebooks. Now, these will not work if you're using something like a Spider IDE. Yeah, so if you have Spider, Plotly is not going to work. It's really designed to work in a web browser, but it's very visual, interactive. You can zoom in and zoom out. So I can zoom in onto this spot right here, and I can see all the details. Double click and you can zoom out. And then it gives you slider controls as well. Yeah, okay. So these Plotly charts are pretty cool. Take a look on Google. Take a look on the Plotly website. They have all kinds of documentation on stuff. You can add in slider controls and all kinds of other fun things, checkboxes, and what else? Radio buttons, controls where you can interact with the chart. Is really cool stuff, right? So over here we have the carriers. If I click on this, or click on another one, you can see how they turn on and turn off, right? So that's how it's interactive. Plus you can zoom in to see whatever you need to see, and you can zoom out, of course, right? Click on this and you can activate or deactivate the different bars. So when you look at this, the chart looks kind of sparse and kind of anemic, but that's okay because remember, we're only sampling 1% of the total population. We had 3 million records. I'm working with 30,000. So if I look at 100 times more data than this, it's going to be chock full of all kinds of arrival and departure and which planes are going to which gates and what date are they arriving and departing and all this stuff. So it gets pretty busy. So it does look a little bit weird, but again, it's only 1% of the whole data. And I don't want to sit here and wait for hours and hours and hours, or who knows, maybe a couple of days for everything to finish off. I'm not going to wait for that. So I just wanted to take a small subset, just a random sample of the population. And if the data is pretty normally distributed, and if you pick from any different part of the data set, it's going to be essentially the same. I think a random sample is totally fine if the data is massive. If the data is kind of skewed one way or another, taking a random sample might not work for you, right? So you really have to consider that as a case-by-case basis. So we look at only 2 months here, January and February of 2019. Remember, I had the start date over here. So here's the start date, 2019, January 1st, and the end is the last day of February. So we only have 1/100th of the data to make it run faster. And to make this a little bit more user-friendly, I'm only looking at 2 months of data. In a real-world scenario, if you had a computer that can process the full volume of data, by all means, that's what you should be doing, right? With my ThinkPad laptop here, it's just not going to cut it, right? So I just had to pick a smaller set of the population. And I think, I don't think I showed you, but it's pretty obvious at the beginning. If you do want to look at the entire data set, just don't take that sample like I did. So the sample comes from, so where is it over here? Before I did the analysis, right? So there it is, fraction right here. So just take the full thing if you want the full thing, right? So that's that. Let me look over here. Okay, so we're up to that. So we saw the chart. So let's look at the cost model now. So how much is this actually costing us and how much is this actually going to save, right? So in data science, pretty much everything comes down to finances. So maybe sometimes you're running experiments in some laboratory just for fun and you create a hypothesis and this is just fun for you and you want to see how this works out and maybe try some different ideas and whatever. Most people that do data science or machine learning or deep learning or AI have some kind of profit motivation behind it, okay? If you're just doing random things just because you're bored, that's okay. That could be a great learning opportunity. But in the real world, really we do things either to save money or to make money. These are really the only two initiatives based on my 20 years on Wall Street that I've seen. I don't think anybody's out there doing this data science charity work. I haven't seen that yet, but maybe there's something out there. But the goal here is either to make money or to save money. So how are we going to do that? We have to look at the savings per carrier. We want to have a minimum and a cost tow fixed, right? We're not going to go over this threshold, or we're not going to deal with this team. Okay, there's a few different teams that can do the towing. If it's more than $800, guys, we're not interested. Okay, we're not going to pay. We're going to save the airline company money, and and that's the goal here. Okay, so I interviewed at one of these airlines a couple of years ago. I thought the interview went phenomenal. The guy was like, "Oh yeah, I love it, I love it. I want to bring you in," and then it went nowhere. Like all these things tend to go all the time. So I don't know what's up with that, but I know a few things preparing for the interview, and in the interview itself. But I never worked for any airline, so some of these things are a little bit foreign to me. I had to do a lot of research to prepare for this this video. So I think this is correct. I put some effort and labor into this thing, so I think it's correct. But if you find some mistake, or if you have some different insight than I got from this, then by all means post it in the comment section. And if you think it's significant or meaningful for you, then let me know in the comment section. I like to get those comments. So here we have like we had before, the arrival, departure, the gate where we're going. Is there any gate conflict? Yes or no? No in these cases. No tow charge. This is the carrier. This is American Airlines. I don't know what B6 is. It just comes in the data. I don't know what MQ is. It must have some code that translates to something else. But the cost to hold, to tow, and the total cost is all zero. So the optimizer is clearly working in this case. Control Enter. So again, we're doing group by carrier and the number of stays, conflicts, total minutes hold. And this is just a small report. It's a small summary report. Like we saw before, the planes were towed to which gates and which gates they arrive, in which order, right? I had the plot over here. So that's what this is over here based on the date and the carrier. So the carrier is on the y-axis and the date is on the x. So that is one report. This is a different type of report. It's almost like a pivot report, sort of, or a what's it called, crosstab report. Okay, there's a couple different terms for this. So we have the number of stays, conflicts, total minutes, total tows. So this airline incurred 2 tows and it's incurred 1. Here's the time. The tow takes about 15 minutes. So you get 15 here, half an hour there. Cost hold, cost to tow, 2,500, 1,250, right? So this is double the time, double the price. Total cost is the same, right? Cost per stay and the cost per flight. Okay, so essentially the same. And these guys had no charges whatsoever. So these guys are looking good down here. Control Enter, and by hour, we have again the time of the day. So AM peak, PM late, overnight, midday, number of stays, any conflicts, no, total cost, and then average cost, pretty low. Total cost is only 1,250. It's not huge for the airline, but these can add up pretty quickly, right? So again, you want to keep the costs down. You want to focus on the financials and efficient operations for the entire airline, right? That's the focus here. So carrier by hour. Actually, let me cut and paste this into one cell. This could easily be one cell, right? Control Enter. Okay, I'm going to delete that. I'm doing that just to clean it up for you guys. I'm going to save this when I'm done and share all the code with you guys. Okay, so just saved. I will do it right now. Right now, okay, as a matter of fact. And then you'll have the HTML file. I'll share all the code with you so you can do your own analysis. So here is another view like we saw before. The pivot is pretty nice. We saw the same thing over here. Pivot, crosstab, basically the same thing. So here we see group by carrier and our bucket aggregating total costs, and then we're going to do a sum. So there's a couple different aggregations you can do. The most frequent clearly is either a sum, a count, or an average. Sometimes you'll see a max, a min, sometimes standard deviation, but those are used to a much lesser extent. Most of the time you're either summing, counting, or taking an average or something. So we can see here the different carriers are in the y-axis or the vertical. This isn't really a chart. It's in the vertical column there overnight. Okay, so we saw our cost for this guy over here, actually 2, correct? Because American Airlines had 2. If I go back here and look, AA had 2 and AS had 1. So that's the 1 right there. We go back over here, so AS had 1, all right? And it was PM peak. So PM was not kind to these guys. AM hurt a little bit, and late evening hurt a little bit for some reason. Maybe there was some weather or some other condition at the arrival airport. So let's look at a non-optimized baseline. So those are optimized. So this is minimizing the operational costs for the airline. Okay, so we had 2 1250s for one carrier. I think AA or American Airlines, and then the other one had 1250 as a charge. So if you do not optimize, right, if you just randomly assign planes to random gates, and it could be far, could be maybe 30, 60 minutes to get into the gate or something like that, it's going to be much more messy and a lot more costly for these airlines, right? So in this scenario, I am not optimizing the output. And if there's no optimizer here running, let's see what the output looks like. So we have the flight type, array, departure, turnaround minutes, preferred gate, the actual gate, gate conflict, no, gate hold minutes, no, 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 no. So we're actually looking pretty good over there. But the baseline total cost is 3750. The optimized cost is 3750. Estimated savings was 0. That's interesting because I ran this the other day and it gave me different results. So let me go back here and rerun this from, do it from here. That might be just like pure coincidence. I don't really care about the KPIs. That's fine. I'll start there and I'll go through it through the scenario again. That was a little bit weird, but just by chance, you could align all the flights or the arriving flights at the right gate, especially at an airport that's not so busy. Although JFK is pretty busy pretty much all the time, so I find it hard to believe that they would just accidentally optimize their schedules, but that could be. That could be. These pilots have a lot of experience. They're working with air traffic controllers, and they get the same result. Okay, well, either way, I guess we're doing good at the airport today because there's no massive problems here. And that was it. I thought we'd see more of a discrepancy between the optimized and the non-optimized, but I guess in this case, I guess we got kind of lucky, like it just worked out here, right? But anyways, that is one way to optimize the charges or minimize the charges for air carriers going to different airports. I picked JFK. You can pick a different airport if you want. JFK, if I just search for that. Okay, so you can pick any airport that you want. You would just replace this with the airline that you want. Okay, if I go over here, the airline would be over here, I think. And where is it? Where are they saying? I think it's I. I think it's column I. No, that's destination airline. Oh, I know. I think it is column I. JFK. Okay. So it's either the arrival or the departure, right? Origin or departure. Let me see one more thing here. Airport goes to airport. Yeah, I know that. Oh, they have both. Okay, so the arrival and the departure. So if you want to look at a different airport, just pick a different one. Okay, so this is going to be either origin or where is it over here? Depart or destination, right? So if you want to see something local to where you live, this is Seattle, Washington. This is Denver, Atlanta, New Orleans, Dallas, right? If you want to see a different airport, by all means, run through the analysis. Just update that JFK that we saw over here to Dallas or Denver or Seattle, whatever you want, and do the analysis and see what the outcome is. So in this case, I think we kind of lucked out because the optimized solution and the non-optimized are actually the same. That's kind of rare, but that could happen. That could happen, right? But I would be much more concerned if the optimizer performed worse than the baseline event, which is non-optimized. Then we have a problem either with the mathematics or the computations got screwed up somehow. Then you have to go back and debug it. But if these two happen to be the same, again, that's highly unusual, but I can live with that. I can live with it. Okay, so I'm going to share all my code with you guys. I'm going to share the source code in my posted video later today. I'll pop that up on YouTube when I get a chance, probably sometime before this evening. Not sure when, but before the sun goes down today. And then you guys can download the code, play around with it, check out the video. Please subscribe, like the video, give me some comments if they're good comments. If they're nasty, I don't really need to hear about that. There's a lot of negative comments on Twitter and Facebook and some on YouTube. I don't need more of that stuff. But yeah, if you have some good things to say, let me know about it. Okay. Thanks for the time today, guys. I'm going to wrap it up and I'll see you in the next one. Bye for now.